Okay, we'll start today's session. Hello everyone, this is Arun. Today is the last week live interaction session for this course, remote sensing and GIS. So in the last class, many students had some doubts on how to solve some problems. So I'll first solve those questions and then we'll go on to the QJS demonstration. So let us solve those questions first. Okay, the first question which was asked was so IFOV of a sensor with spatial resolution one kilometer, then swath width is given as 250 kilometers, and scan angle 10 degrees. How much, and the value should be in radian. So this was the question which someone had doubt. So by definition, the IFOV of a sensor is defined as the spatial resolution divided by your altitude at which the sensor is located. So if it is a northern looking, then you should use this equation. If it is off northern looking, then your equation will become H secant phi, where phi is the side looking angle. So these are the two equations. Now if we want to solve, so in question the spatial resolution is given. So here they did not say whether it is side looking or northern looking. So we can go with northern looking itself. So by default. So this is your spatial resolution. So which is given in the question as 1 kilometers. But your altitude of the sensor, that is not given. So but instead there is another information. So we have the swath width given as 250 kilometers and the scan angle is also given. So there is one more relation. If you want to find swath width, two h tan theta by 2. So now you should understand what is this theta. So if you are going to use a equation which has theta by 2, then your angle is basically so let's say here is our sensor and it is focusing on the ground. So this is your ground level. So this is your height h. So if you are using theta by 2, then your angle, whatever you are using, should be the entire angle. But by definition, the scan angle is so I divide this entire field of view into 2, and this angle, whatever is from the northern point to your other edge, that is your field of view. This will be your theta by 2. So in this question, they have just given this scan angle. So whatever the angle they have given, it's directly the scan angle. So we can make use of this relation to get your altitude h. So we will find out. So 250 kilometers is equal to 2h into tan 10 degrees. So if we find out the altitude will be 708.91 kilometers. Now once we know the height, we can substitute back in the IFOV equation. Instantaneous field of view is equal to d by h, which is nothing but your spatial resolution is given as 1 kilometer. So I am substituting it in kilometers itself, and your height is 708.91 kilometers. So your IFOV will be 1 divided by 708.91, which is nothing but 1.410 into 10 power minus 3. The unit is in radians. So I hope this part is clear. So anybody is having any doubt? Okay. So another question was, this is the second question. So your RMSE is given out, is found out as 0.85 when applying a geometric correction. And this is applied on a Landsat 8 some band, let's say band 4. Then question is, what is the expected what is the expected accuracy of measurement? And 4 options were given, if I remember. So one was 5.5 kilometers, then one was 25.5 kilometers, then 2 more options were given. So this is a direct question. So now you need to look at your Landsat 8 band 4. What is the spatial resolution? So the spatial resolution of Landsat 8 is 30 meter spatial resolution. So your expected accuracy will be 30 into 0.85. That will work out to be 25.5. Sorry, this is in meters. Everything is in meters. So your expected accuracy will be 25.5 meters. It's just direct multiplication. So whatever satellite data they are referring to, you can find out what is the spatial resolution first, and then whatever is the RMSE given, you can just directly multiply to get your answer. Then third question was total emitted radiation from the surface of stainless steel at 320 Kelvin. So you have the black body equation, that is so your equation is total power emitted is equal to sigma a epsilon t power 4. Here let's say you are finding out for per unit area, so this will be gone, and temperature is in Kelvin. So in question, actually they should have given this epsilon value emissivity for a steel, because if you search for emissivity of steel, you will have different ranges. But when I found from a standard textbook, it was given out to be epsilon is equal to 0.59. This was what I could find. So when you substitute P is equal to your Stephen Boltzmann constant into 0.59 into 320 Kelvin to the power 4, it should be approximately near 95 to 99 watt per meter square. So if I calculate Stephen Boltzmann constant, so that is 5.67 into 10 to the power minus 8 into 0.59 into 320 to the power 4. So okay, this is not 95, so your P is 5.67 minus 8 into 0.59 into 320 power. Yeah, 350.78 watt per meter square. This should have been the answer, but I don't know. Some previous year question, it was just a open-ended question, so anybody can use any value of emissivity to get your answer. So the value should have been provided in the question. So is this fine? So any other doubts related to this?
Sir, same question answer is given in this year assignment, uh, 95 watt per meter square.
Same. How can
Same question, sir.
same question? Okay. So actually, the emissivity should have been given in the question. Otherwise, there is different values
Sir,
for.
there is not given in emissivity, the value of emissivity.
So that should be given. Show the first question. Huh? Okay. Emissivity should be given. Uh, Otherwise, it's not possible to solve, because anybody can solve with any emissivity coefficient. Is this visible? First question.
Yes, sir. First question is
Yeah.
understand. The second question, last time I have told that, sir, that should be multiplied with 30.
Yeah.
But the third question that in this year this assignment is given in week 5,
Okay.
and answer is given 95 watt per meter square. And they are taking that the emissivity value is 0.167.
Okay. But still, by any standard table you refer to, the emissivity is given out to be in the range of zero point 0.5 to 0.59. So I don't know why it is taken as 0.16.
Sir, one doubt or one thing week from week 1, sir,
Okay.
there one question is given that optical image captured at a night is an example of active remote sensing. So this one is true, na?
Optical image captured at night. See,
At night.
your optical sensors, they don't have the source of their own source of energy. So they have the sunlight's energy as the electromagnetic radiation source. So it is not optical images. If you capture at night, you will not be able to see anything because there's no sunlight.
So this
Only
one is passive.
only your thermal sensor, which is present as a number of bands, only your thermal will record something because the water bodies at night, they will be at a higher temperature when compared to your lamp, so they will emit your thermal radiation, but your rest of the things, nothing will be visible.
So this one is not active remote sensing.
No, it is passive. Optical is passive remote sensing.
Oh, okay.
Okay. If you have noted down the first question, I will also share this as a PDF, so you can also download it from the Google Drive.
Also, can you share the previous year question paper?
That I'm not supposed to share. The NPTEL team has to share that. Okay, so let's go with today's demonstrations. So in the last week, I gave a detailed overview of what is GIS and what is the difference between your data and information. Then some applications. Then we saw what are the two types of data that we use in GIS, that is raster and vector. Then what is the difference between those two data types? Then we saw the how the uh, raster looks like, how the vector looks like. Then I described about what is meant by small scale and what is meant by large scale. Then we saw the map layout and what are the important elements that should be present in a map layout. Then finally, one of the most important thing that is required to work with any GIS data, that is your coordinate systems. So what is geographic coordinate system? Then what is a projected coordinate system? And I just quickly demonstrated how to reproject one data layer. So today we will see. So last week doubts I just completed now. So today we will see how to reproject a raster data layer and a vector data layer. Then if you're having a very large area, so I told in the last week, your UTM 44, your UTM projection, they are all in the form of thin cylinders. So So your entire globe is divided into every 6 degree longitude. You have different zones, and India lies between, I think, if I remember, 46 to 48 or 49. So let's say your India is somewhere located here. So it is crossing different zones. So you cannot just assign one single projection to entire India. So like that, when you have a large study area, I told about one projection. So Lambert Conformal Conic. So which means you are going to have a cone that is cutting your uh, globe at two certain points. So it is a secant data type, and when you are opening the cone, so it will look something like this. So this is related to the development of surfaces that is in your engineering drawing. So this is your first latitude, first standard parallel, then this is your second standard parallel. So along this standard parallel, your distortion will be minimum. So your area calculations, your measurements, whatever you are going to take, will have less distortion error. So today we will also see how to define a user defined projection, that is your Lambert conformal conic for the Indian subcontinent. Then I'll demonstrate how to make a map layout. Then another important thing that is needed in GIS is digitizing. So your survey sheets, your topo sheets, everything will be in the form of a map. And in the maps, you will have some key points. So first you will georeference that. Then after georeferencing, you will digitize the features that are present in the map as points, lines, and polygons. Then we will add some information to it. We may have to calculate the area, or we may have to calculate the distance. So that can be done by using the fields and operations. Then while digitizing, there are some issues. So they usually occur with snapping, and they are called as slivers and overlaps. Then we will see how to quickly digitize some of the layers by using the advanced digitizing tools. So first is reprojecting a data layer. So this is the sample snapshot of a QGIS window. So here if you go to raster, projection, then warp reproject, this dialog box will open. So here you need to just give three information. So one is your input layer. So which layer you are going to reproject, that is your input layer. Source CRS, it is optional, so you don't have to give it. Then next is your target CRS. So which projection system you are going to reproject to. So whether you are going to project it from WGS 84, the default one, to the UTM projection, or your user defined projection, or any other projection system. That is your target. Then here you need to save your file with a specific name in a separate folder. So this is for a raster layer. So similarly, you have, if you go to vector data management tool, reproject layer, so you will have your another dialog box. Here you need to just give the input layer, your target CRS, and your file name. So these are the two different things. So now I will show you how to reproject one of the data sets. So I just opened a new project. So this is one of the raster layer. So it's a TIFF file. I'm going to load this. So you can see this is a map. So this is a soil map, and this is for Tirunelveli district in Tamil Nadu. So you can see, so this is a geo-referenced map. So this is already projected. So I'm just going to make a small change. So I'm going to raster for pre-project. So the input layer is already here. So only TN soil sheets. Then you should go to the target CRS. So you should click on this select CRS button. Then I am turning off this checkbox. So here you can select whichever projection system you want to change it into. So currently this is in I think 43 north. Okay, if you see here, it is not a projected system. So last class also I told. So if it is, so this is the coordinate system that is present. So if it is WGS 84 geographic, it is in the spherical coordinates. So it is in the form of a 3D model. So we need to project it to the 2D plane. Only then we will be able to calculate the area, measurements, whatever we are going to do with this data set. So WGS 84 is unprojected. So this is unprojected. So now I'm going to project it to EPSG 32643. So this is WGS 84. This is UTM 43 north. So this comes in the part of the Western Ghats. So the projection system appropriate for this region is UTM 43 north. So this is your projected coordinate system. So I'm going back to the QGIS. So I am selecting this. So here I'm going to search for UTM 43N. So here you can see different 43 north. So these are all some of the old system. So Kalyanpur is the place where this UTM 43 north has its tangential point. So it is having the minimal distortion at this place in India. And WGS 82 is again outdated, and WGS 82B, this is also outdated. So we can use this 43 north. So when I selected this, you can see this strip has come into the our entire map extent. So you can see it is over the Western Ghats of India. So it is somewhere there. So I'm just going to click OK. And then I'm going to save this. So there is a small shift. I don't know if it is visible. So you can see this difference, right? So I'm turning off the reprojected layer, and the bottom layer is visible. There is 1 pixel shift here. So this is a very minute change that has happened. So other than that, it is fine. So it has not distorted too much. So that amount of error is acceptable. So I'm going to remove the previous layer. So this one layer will be there. So this is how we can reproject the raster layer. Next, similar thing, we can do it for the vector layer also. So I'm going to bring the India shapefile. So here you can see again it is not projected. So we need to reproject. So vector, data management tool, reproject layer. And India is a very big country. So I'm selecting UTM 44 North. So this is the projection I'm going to change it into. So you can see here. So here the entire country is not uh, taken care of. So you are going to have lot of distortions, but this will not be visible in your QGIS window. But when you are calculating the area, only then it will be prominent. So I will show the example by comparing it with the custom projection. So I'm just going to reproject it to 44 North. I'm going to save this file. And then I'm going to run it. So now this is reprojected, but you will not be able to see any distortions. So that is because there is a option called as on the fly projection in QGIS. So it will not show how much distortion has happened just for the uh, user interface. Otherwise, you will be confused where the layer went. So this, when the on the fly projection is turned off, this layer will disappear. So it will be located somewhere else, and that becomes a little bit difficult for us to work. So I'm going to remove the India fixed. Okay. So this is how you can reproject your raster layer and your vector layer. Next thing is now we need to just now explain. So for the entire India, that one UTM 44 is not justifiable. So what to do in that case? There is no other projection system which can take care of this distortion. So in that case, we need to define our own projection system that we can do it by the custom projections. So the important information that is needed to do this is, so we are going to define Lambert Conformal Conic projection system, and to do this we need two informations. What is the latitude extent and what is the longitude extent? That is your minimum maximum latitude of India, then minimum maximum longitude of India. So these two are the parameters that these two are the information that we need. And coming to the Lambert conformal conic projection, so we need to set four parameters. First is mid latitude, then second is your central meridian, third is standard parallel 1, and fourth is your standard parallel 2. So mid latitude is just your average of maximum and minimum latitude. Then central meridian is average of maximum and minimum longitude. So this is straightforward. Next thing is to calculate the standard parallels. So while defining the standard parallels, there is a thumb rule. We should place the standard parallels at 1/6 of the latitude range below the top and above the bottom of the area to be mapped. So this means, so let's say that this is our study area. So here is your maximum latitude, then here is your minimum latitude. We should place our standard parallel such that this distance is 1/6 of the range. So this distance also is 1/6. So which means your standard parallel 1 is maximum latitude minus 1/6 times of maximum latitude minus minimum latitude, and standard parallel 2. So this is standard parallel 2. Standard parallel 2 is minimum latitude plus 1/6 of maximum latitude minus minimum latitude. So this is how we have to place. So we will find out what is the extent of India. So I'm going back to QGIS. So I don't want this layer now. I'm going to bring in the previous layer which I used. So if I double click on it, this window will open. And here it is unprojected because we need it in terms of degrees and minutes, seconds. So this is in decimal degrees. So this is our extent. So I'm copying it to the Word file. So we will take this. So this is your minimum longitude. So this is your maximum longitude. This is minimum latitude. Okay, now I want you to calculate what is the central latitude and central meridian. So can someone quickly calculate and tell me? Is anyone doing it? Okay, your central latitude is 21.91 degrees and the central meridian is 82.80 degrees. Next is the range of latitude. So that will be 37.07 minus 6.75. That is 30.32. Now I am going to divide it by 1/6 of range. So that is 5.05. Now my standard parallel 1 should be maximum latitude. So that is 37.07 minus 5.05. So that is 32.01. And your standard parallel 2 is 5.05 plus 6.75. Sorry, 6.75 plus 5.05. So that is 11.80. So now we got all the necessary parameters that we need to define a custom projection. So next we will see how to set. So when you go to QGIS, settings, custom projections, when you click on it, you will get this dialog box. So first there will not be anything here. So we need to give a name for it, and then we need to click the plus button. So it will get automatically added. Next thing is here we have something called as a format. So all your projections are mathematical. So it is going to read this particular string. So whatever is given in this box. So your Python is running in the background. So it will read this and then it will take the parameters from this to do the further processing. And to get this, initially there will be nothing here. So we need to click on this icon near the validate button. So it will take you to a new window. And then from there we will copy and paste it. So once we copy paste it, here we need to give our all the values whichever we just found now, and then we need to validate. Then once you validate it, your custom projection will be loaded in your system and you can use it whenever you want. So once you do this, it will be only in your system because you have defined it. So it will not be anywhere else. So if you try to access this projection from some other system, it will not be available. So it will be stored only in your system. So now I will show how to do this. So I'm going to QGIS. So this is my unprojected layer. I'm going to project this. So I'm closing it. So I'm going to settings, custom projection. So I will just remove this. So this is how it will be when you are doing it for the first time. Nothing will be here. So first I need to give a name. So I'm going to give India Lambert Conformal Conic user projection. So this is what I'm going to do. Then I'm going to click on this copy button. So it will take you to this window. Now from this, what we need to do is we need to choose a projection system that is approximately accurate for India. So since I'm using the Lambert Conformal Conic, I will go to Lambert Conformal. So Lambert Conformal Conic. I have searched. So from here you can see there are so many Lambert Conformal Conic. From which one I need to copy the parameter. So whichever best represents India, from there we are going to copy it. So Africa we cannot use. Then Asia we can use. Then Asia North. So if I see here, so your southern part is missing. So it's not going to give you the proper projection. Here the top part, Kashmir and the northmost states, they are missing. So this also will not give me the correct one. So rest will be in different continents. So best thing what I can use is I can use only Asia Lambert Conformal Conic. So I have chosen that. Once you do that, so here this window WKT is there. Now if I scroll down, so you can see Proj 4 and you can see 2 lines. So this is what we want. So I'm just going to copy it, Control C, and I will close this and I will paste it here. Okay, I have done until this point. So what is the next step? So we have chosen the Asia Lambert Conformal Conic and we have taken these 2 lines, copy and pasted. So this is what is the string that looks like. So here you have so many things. But what we need is the ones that are highlighted in red. Lat 0, lon 0, lat 1 and lat 2. So lat 0 means that is your mid latitude, lon 0 means that is your mid longitude, then lat 1 is your standard parallel 1, lat 2 is your standard parallel 2. So we just calculated. So initially this will be 0. Lat 0 equal to, it will be 0, as you can see from this image. So without changing anything else, so without any space or without any changes, we are just going to delete that 0 and type in this number. So I will do that in QGIS now. So your lat 0, so I have pressed the backspace button. So lat 0 is 21.91. Then lon 0, here it is given 105, so I am deleting that. And central meridian is 82.79, so I have given that. Then lat 1 is given as 30, I am deleting that, and then I am giving 11.8. And the lat, oh, your standard parallel 1 is the one which is at the top, so that means your this is your lat 2, this is your lat 1, yeah. So standard parallel 1 is the one which is at the top, so top most latitude is higher, so 32.02. So your lat 2 is 32.02 and your lat 1 is 11.8. Once we do this, here this format is known as proj string. So I am going to select that proj string and then I am going to validate it. So this should be your output. The projection definition is valid. And then I am going to click OK. Now I am going, this is a vector layer, I am going to reproject it. I am going to vector, data management tool, reproject layer, and I am going to the target CRS. So we need to go to the user defined. So I am going to minimize this. I am going to minimize this. Okay, it has not come. Okay, I forgot to give the plus button here. So I clicked on the plus button, then India underscore LCC underscore user defined. So I'm going to paste that string. Your lat 0, 21.91. $82.79. $32.02, and last one is 11.8. So I'm going to validate. It's valid. Okay. Reproject layer. So now you can see. So India user defined projection system is available. And then I'm going to click OK. So I have reprojected both the layers. Now let's see what difference this brings in. So next thing is once we have reprojected, we can calculate the area. So to calculate the area, we need to do the right click, open attribute table. So this is your database. So here I'm going to click on this pencil kind of icon. It's called as toggle editing mode. So I click on that, and then I'm going to create a new field. So which means I'm going to create a new column. So create a new field, and I'm going to give it as area, and area will be in terms of a decimal. So what kind of data you are going to store, this should be predefined. So decimal number is your area, and length also we should give. This is used to define specific space, so that your file size is appropriately created. It's not too much. So I don't know how much will be the area, so it's definitely going to be very large. So I'm giving 20 decimals, 20 places, and I want at a precision of let's say 4 decimals, and I'm clicking OK. So your area column got created. Now next is calculation. So in QGIS we have something called as open field calculator. So I'm going to click on that. So now it has opened a dialog box. So since I have already created my area column, I'm going to update that column. So I click on this, and if you see here, you have to select area. And now we need to calculate the area. So we have a predefined Python algorithm. So from this list of uh, things which are given here, we need to go to geometry. And if I click on this drop down triangle button, so here you can see area. And similarly, if I go down, there are so many functions. What we will use is mostly length. Then we will also use perimeter. Then you can explore this by yourself. So you can use n number of operations that you can do here. Mostly what we will do is we will find the length, or we will find the distance. So distance also will be here. Yeah, distance is here. So I'm going to calculate area. So double click on it, it will come here. And you can see the preview also in this bottom. So if sometimes you can see uh, if it shows a negative value or something, then something is wrong with your projection system. So you need to make sure that whether it is projected or not. So now this is in terms of a meter square. So everything is in terms of a meter square. So if I want to change it, I can change it. But we are going to see some difference. So I'm just going to keep it in meter square. I click OK. So now you can see here your area has come in this place. And once you do all the editing and everything, again you need to click on this pencil button to save it. So otherwise it will not save. So I'm going to save it. So similar thing, I'm going to do it for the UTM-44 also. So I'm going to create again area, decimal 20, then update your existing field, geometry, area. I'm going to click OK. So I'm going to save this also. So we can see what is the difference now. So can someone tell me which area will be accurate? So whether UTM-44 will be accurate, or user defined will be accurate? Anyone? No, it is not copying. Okay, so we will see what is the difference. So this is LCC area, and I will change it to number itself. And I'm going to bring in the other one also. Okay, let's see which one is accurate now. So I'm going to search India. So it is given as this much square kilometers. So I'm going to convert it into meter square into 10 to the power 6. Okay. Now let's see which one is accurate. Okay, there is some issue. Three two eight seven two six into 1000. So this is in 1000 hectares now. So you can see. So meter square divide by 10 power 4 is conversion to hectare, and divide by 1000 again. So that is 10 power 4 plus 3, that's 7. So you can see the difference in the decimals. So it should be 726. Uh, Last three digits should be 726. Uh, if I show it in the full format only, it should be. So this is multiplied by 10 power 7. Okay. So your this is the country area, and you can see the difference. So your UTM-44 is giving only 119.7, and your LCC is giving 134. So your LCC is obviously better than UTM-44, but it is still nowhere close to this 328. So this is only giving 327. So which means it still has some distortions, but this is the best that we can achieve right now. So you should go to the most accurate one as possible. So the LCC is obviously a better option than your UTM-44 North, and this will be highly reflected when you are calculating the area of the states. So where each state will not give you the accurate results, so that time it will be a issue. So it's always good to have your Lambert Conformal Conic user-defined projection as your system. Um, is this clear? Okay, next part is what we call it as digitizing. Next is okay. Let me do the map layout, so that will be useful. So I'm going to bring in another shape file. So that is India states. So this is the state map for India. So to create a map layout, we have to go to project, here new print layout. So I am going to give a title, map 1. So it will open me a new window. So this is your map limit. So I think currently this is in A4. So if you want to change it, you have to go to layout, and then you have to go to page setup, and you can change the page properties here. So within this only you need to work. This is your space. Next thing is, on the right side you have the different properties. So once you bring in a layer, some more properties will be enabled. So currently this is the property of the layout. Then if I click on the item properties, so since nothing is here, this is not visible. So let me add something. So to add whatever the layer that you are opening in the QGIS window, what we have to do is we need to go to add item, add a map, and then I'm going to draw it as a rectangle. So I'm leaving some space for my coordinates to come into the frame. So the moment I leave my cursor, the entire India extent is visible. So now if I click on the map, so you can see map 1 is added. Now I go to the item properties. So here you can see several options that are enabled. So we will go through one by one. So right now, let's say that now since only one layer is there, so the size is also big. So this entire thing is coming very nicely on the layout. But suppose let's say if it is somewhere like this, if it is coming like this, or if it is like this. Now what can you do to change this? So on the left option, there is a select or move item. So that is to move your map frame. So by this your map frame can be moved, but whatever is inside that it cannot move. So there is another tool, move item content. So whichever thing you want to move, you have to select that first. So I am selecting this first. and I'm clicking on this move item content button. Now if I start to move, only whatever is inside is going to move, and I can zoom in. So scroll up, it's going to zoom in. But there is another way to zoom in. You can hold the control button and then you can zoom. It will zoom little bit controlled way. So it will not, if I do without control, so it is, you will not have control over the how much you want to zoom. For minor adjustments, we need to use, you need to press down the control button and then you can zoom in or zoom out. Then you can move your click and move your layout like this. Then I can zoom in again. So now this seems to be in good position. So I am leaving that. Next, how to create a inset map. So I'm going to add another map. So I'm going to use this corner. So you can see. Now map 2 is this small one. And I'm going to adjust this also. So for fine adjustments, this place, this is where the control will be useful. So you can finely adjust. So I have kept my map. So now I'm clicking on the first map and then I'm going to the right side, and there is something called as frame. So it will give you the border for the map, and then so similarly for map 2 also you can give a frame, and you can use your arrow keys to move it. So now it has now I have moved. And there is one more thing which you need to remember in this. So I bring in some other layer and you see what happens. Now I brought in a new layer, and if you see, both the things changed, but I want my state map to be on the map 1. So my map 1 should have only the state, but how to make this happen? So first thing what we need to do is whichever thing that you want to set in your inset map, you set that first, and then there is something called as lock layer. So you need to select the map 2 and you need to lock it. So lock layer and lock style for the layer. Next thing what you have to do is you need to go back to the QGIS, and I'm going to turn this layer off so that my state is visible. And I'm coming back here and I press this refresh button. So now you see your inset map has not changed because we have locked it, and your map 1 has changed. So this is how you can fix your inset map first and then come back to the state map. So next essential thing that we need to add in the map is your scale bar. So add item, scale bar. So I'm just dragging it. So your scale bar has come. And here if you see, the scale bar also has some option. So left one means you will have different types of scales. So it's always preferred to have a left as 0 and right as 2 or 3. Depends on the scale of the map. So this is a little bit a very larger map. So let's have right as 3. And you can also change this width. So right now it is in 250. So I can also have it 100, but your scale looks very cluttered. So let's have 500. So if you have 500, I think right 2 is sufficient. But if you have 250, I think it should be right 3. So let's say 250 and we can have right 3. So I have fixed my scale bar now. So next thing is I need to have a title for the map. So you can go to the add item, then add a label. I can just draw it here. Then here you can give the title. And I can change my font. And you can align it here, center, middle. So we can set the layer title like this. And next thing is you need to have north arrow. So add a north arrow. And here you have different types of north arrows. So if I click on the arrow, you have different types. So let me choose this. And you can change the color of that. So I have added a north arrow. And the last important thing that you need to have is your grids. So when you go to the grids, you can click on the grids here, plus button, grid 1, modify grid. Now you need to give the offset. So at which interval you want your lines to be present. So let's say I need to have it for every 10 degree of longitude and 10 degree of latitude. So your grids have come. And now the lines are very thick, so we can scale it to a different color so that your other things are visible. So I prefer to have a light gray color. Now we have added only the grids, but we need to know what it represents. So here we can use the map CRS itself. And if I come down, draw coordinates. So you can see everything is in terms of decimal, but there is no whether it is north, south, nothing is given. So if I click on the format, you have several formats. So we can go to degree, minute with the suffix. So this is for left, right, top and bottom. So I need to do for everything. So left should be vertical ascending, then right should be vertical descending, then top is outside the frame, then bottom is also outside the frame. You can change the font also here. So I'll choose Arial, then and distance to map frame. So how much far away from the boundary it should be. So let it be little far away. And here is the grid rotation option. So if you have some rotation in your grid, so let's say I'm going to give 25 degrees. So right now it does not have anything, so it's not visible here. So if I have some rotation and if I set to 0 degree, it will become exactly perpendicular to the map frame. So since I don't have any rotation, I'm just skipping it. And then there is one more thing which you can add. So frame with interior ticks, so which means your small things here. So these are the small things that are going to change. So interior tick, exterior tick, then you have zebra means your border itself will be like having the distinction between the grids. So I usually have the interior ticks, and you can change this precision. So this I will set to 0. So it is 90 degrees 0 minutes east. So this is how you can create a map layout, and you can save it. So layout, you can export it as a PDF, you can export it as an image. So let's do some analysis on this. So if I open the database of the shapefile, so you have different populations. So we can represent each state with respect to the populations that they have. So to do that, double click on this India states, then go to symbology. So here you have something called as a graduated. So graduated means for the same population, so it's going to show me in multiple colors. So I'm going to click graduated, then so pop admin, that is your total population, and I'm going to have the precision as 0 itself. So you can see from the least population to the highest population, it's going to show in different colors. So here you can change to different colors. So once you click on the classify, it will show me the classes. You can increase the classes, you can have a more number of classes. Let's say I want to have 7 classes, it will add, and then I'm going to apply it, and I click OK. So you can see the states whichever is very dark red in color, it's having a higher population. So let's have a little classes so that there is some distinction between the red itself. And here you can change how I want to separate the data. So equal count means, so each class will have equal number of states. So let's say the least population states will be categorized into white itself, so there will not be any distinction. So usually what we do is we go to the natural breaks, that is your Jenks algorithm, and then we just click on apply. So here you can see very distinct classification has happened. And on top of this, there is some other data that's given to us. So the last 4 columns represent the population in different age groups. So we can also represent this in our map layout. So how can we do that? So I'm going to double click on this, and here there is something called as diagrams. I click on the diagrams. So I clicked on the diagrams. So currently there is nothing. So you can show it in the form of histogram, stacked bars, or anything like that. But for this data, pie chart representation will be very distinct. So I'm going to give pie chart, and I'm going to select my columns which are having the data. So 1, 2, 3, and 4, and I'm going to give plus. And we can give colors here. So young population, I'm going to set a green, light green. Then little bit mid-age, I'm going to set yellow. Then next I'm going to set a orange color. Since red is already given, I don't want to confuse, so I'm going to give a light pink color. Okay, then this is the color of the chart. Now we can set how it is going to render. So opacity means whether you are going to put some transparency. So I don't want to put some transparency, so let it be. So my line should be in black in color, and we can set the line width, that is your boundary of the chart. So I'm going to give 0.25, and then next is size. So what we can do is we can either give a fixed size or a scaled size, but if you give a fixed size, so it's not going to it will be okay, but then we can also give a scale size. So what this will do is, based on the data that we have, it's going to scale the pie chart size. I'm going to scale it according to the total population. So whichever state that is having a higher population will have a higher pie chart will be bigger for that, and for the rest of the state will be smaller. So I'm going to give the pop admin, and this maximum value and size that we need to play it a little bit. So once I give let's say, so I give apply. So I think it is not visible. Okay. So now your pie chart has come. So population admin, I need to find the maximum value. So it has found it, and then size. So now it is, everything is overlapping. So I'm going to reduce the size little bit. So let's say I'm going to have 3. So this is little bit reasonable. Let's say I will yeah, okay, this will give me a better representation. So let me give 10. So I need to play with numbers little bit here. Okay, now I think this is the best we can represent. So the states which are having very less population, they are not at all visible. Okay, so this is little better. So I'm going to give apply. So these are some kind of analysis that we can do. Now I go back to the layout. So I did not lock my first layer, so I give refresh. So now this has come. Now I need to give the legend. So we don't know what this represents. So add item, I'm going to add a legend, and I'm going to draw it somewhere here. And this gave me whatever is present in the QGIS window. So these are all the layers that are open. So everything will be displayed here. But we don't want that. We need to represent it in some specific format. So once you add it, under the item properties, auto update will be there. Just turn it off. So I don't want the India fixed first one to be there. So I remove that. So I want my second layer that should be present. What this represents is the population. So it represents the state population. So I change the title, and then so I'm going to change this also. And here also you can have different fonts. So title font, then subgroup font, then your item font. Then you can change the spacings also. So below heading, here we will change space between the symbols. So you can see the difference. So let's have a compact and then symbol label space. So this will increase. And then I can give the title here. Can change the alignment here. So now this map layout is complete. So we can change the name also. Let's say demographic map of India, which represents the population. So this is how you can create a neat layout, and then we can export it as a PDF. So save it in desktop. So your layout is ready. So this is how we can create a good layout in QGIS. So any doubts? So I will share this data set so that you can rewatch and work on your own. Okay, coming to the next important part, that is your digitizing. So I initially had one soil layer. So I have just loaded it. So we are going to digitize this map. So which means we need each of this lines as an individual polygon. So what we are going to use is the vector layer. So you can create it by new shapefile by clicking on this icon, new shapefile layer. Then you can, I'm going to create polygons. So set it as polygon. Then projection is 43 north. So this data is for Western Ghats. Then I'm going to save it. Soil digitize. Click on OK. Now I select that layer. Then again I use this pencil tool to toggle the edit. And then here you can see create a polygon. So add a polygon. So I need to zoom as much as possible, and then I am going to trace this layer. So once I complete, I press the right click, it will ask me for the ID. So ID you can give it as 180 itself. So similarly I need to do for each and everything. So let's say we do one more thing. So this is 219. So in a similar way, what I will do is I need to digitize the entire thing. But this kind of digitization will create one issue. So when I am going to digitize this part, let's say two adjacent parts. So let's say I have something like this, and I also want to digitize this layer, so the dark red patch. So when I start doing it, I need to follow whatever clicks I have made for the previous polygon. So like this, one by one I need to make it. So that will be a very difficult task, and sometimes what we will do is we will miss some points. So we will be doing it very fast and we will miss some points. So because we cannot click each and everything separately, so if I do it very fast, so you can see something, some gaps are here. So such kind of gaps will create error, or if you have a overlap. So if I select this point and then I show you the vertex, so here you can see some overlap is there. So this will double account. So when you want to calculate area, so it will account for this area twice. So that error also will be there. So we should avoid this error. And one more error is called as a sliver. So it's called SLIVER. So this means, so when I'm doing it, so I will have this kind of overlap. So when we are doing fast, we don't know. We will not be going like this much zoomed in. So we will be doing like this, and sometimes when we are going to the turns and all, we will have this kind of error. So this kind of crisscrossing will happen. So once you do it, and you will not be able to find out where this error is. So it is better to do it in a different way than to make this error and then sit finding it out one by one. So that kind of errors can be avoided by using one method. So I will show that. So I need to go to project, snapping options, and this toolbox will open. So here what we have to do is, we have to click this all layer, go to advanced configuration, and it will show me the vector layers that are available. And here you can see allow overlap. So I don't want any overlap to happen. So I click on the follow advanced configuration and I select this layer, and here I give you the avoid overlap. So once we set this, it's not going to overlap again. So let me show the same thing again. So let's see what it is doing. So I have digitized this. Now I'm going to the boundary. I selected one vertex, then I just go inside just for the sake. I do it completely inside and I come out here, and then I just close it like this. Right click. Okay. Now we can see what it has done. Now I'm going to select this and I'm going to select my vertex again. So this is the vertex tool. See, although I have digitized it completely inside, So here I was doing something. It has not created that layer, so it is not overlapping. So let me turn off and then demonstrate it again, so you will see the difference even more clearly. Snapping options, I turn off the overlap and I draw another polygon. So I just go inside again. So this is how I was doing it. So I just close it here itself. So you can see now what has happened. Let's say I select this again. Now you can see the difference, right? So there is a complete overlap of this polygon. So let me select this one and show you. So you can see there is this much amount of overlap from here to here. So this we can avoid by simply turning on the avoid overlap thing, so that you will not end up with slivers and your gaps. So when processing the vector data, you will not encounter such kind of errors. Okay, next is vector data processing. So I have already digitized layer. So this is something which we digitized for one study area. So it has the different soil IDs. So you have object ID and soil ID. And if you see here, there are so many number of 85 and 133 and different soils are there. So if I want to select 185, so only one is visible. So I want to see by one click, I want to see what are the 85s that are available. So to do that, we can go to vector, geoprocessing options, geoprocessing tools, dissolve. So what it is going to do is, whichever is having the common IDs, it is going to have only one uh, per ID. So it will take only the unique values and then it will have only one single polygon. So I will run it and show it to you. So dissolve field you have to select is the soil ID and then click OK, and I am running it. So now I open this. So from here itself you can see what has happened. So something got merged together. So now if I open, so 85 is only one time, 133 is one time. So everything is become only one polygon. So if I now want to see the 85, I select here. So you can see what are the number of 85s that are present in the area. So dissolve option will merge all the common polygon into one single polygon, and then it will show it to you in the map frame. So this is the example of dissolve. So it is very handy tool for us when we are handling the soil data, land use data, and all the other things. Next thing is, I am having some examples. Let me load that. So rectangle overlay. Then you have line. You have points. So these are all some polygons which I randomly created. So first I will show you what we can do with the lines. So this is one line, but if you are digitizing some road, let's say you are digitizing along the center line of the road, and then later you want to increase the width. So what we can do is we can use buffer option. So geoprocessing tool, buffer. So it's for line, polygon, you can do for anything. You cannot do it for points. You can use for line and polygon. So I'm selecting the line, then distance, how much distance you want to do it. Let's say I want to do it for 20 meters. So here is the unit. And we can leave all the other things to the default and you can just run it. So you can see, I will show you the line first. So this is the line. Now it has become a 20-meter wide. So I will also measure the length in, this is area measurement, measure a line. So I'm going to measure it. I think there is some issue. So this should be 20 meters wide. So it is a 20-meter wide buffered line. So this is how we can make use of buffer. So next, coming to the rectangles, we have different options. So first I will demonstrate dissolve, I have told. Next is difference. So it's going to subtract one polygon from the other polygon. So rectangle and rectangle overlay. So your input layer and overlay layer. So it will subtract input minus overlay. You will get your difference. So you can see what happened now. So whatever the green portions, it got removed. So this is how the subtraction will work in QGIS. So next thing is vector geoprocessing intersection. So only the common parts is going to come now. So again, two inputs, rectangle and rectangle overlay. So it's going to intersect both. Right. So I'm going to turn off this and I'm going to show the common parts. So only the common parts between both the polygons, only those has come out. And if you also see the database, you will have different IDs. So 4 polygons. So you have 5 polygons and 5 database features. So this also will get updated. So this is intersection. Next thing is union. So in union, what will happen is, so if you see here, we have 3 here, and then 3 in this also. So by making use of the union, your output should have 6 rows. So it's just going to overlap with each other. So next is your union. So overlay layer is a rectangle overlay. I am going to run it. So you can see what union has made. So it has added everything together. Now if I go to the database, you should have 6. So you have 10. So it has double accounted the common areas also. And those common areas don't have, so from the first polygon, so let me explain this. So your first polygon has only 3 rectangles, and your union polygon, this will be counted as 1, this will be counted as another 1, this will be counted as another 1. This intersection will also be counted, and this also will be counted. So totally you have 3 in the each original files plus 4 plus 5 polygons. So you have 1, 2, here you have 3 polygons. So that is your total number of union. So it just added everything together. And this is with respect to the polygons. Now let's come to the points. So more than anything, what we need is only the points. So let's say these are all some rain gauge stations that are represented here, and we need to construct a Thiessen polygon for those who are not from the hydrology background. So I will just quickly demonstrate what is Thiessen polygon. So if you have station 1, station 2, um, station 3, then station 4. So what we will do is we will connect everything by a triangle first. So this is one triangle and this is another triangle. And we have to take the perpendicular bisector of each of the side. So this is a perpendicular bisector. And once we do this, so this is your station 1, station 2, station 3 and station 4. Let's say the boundary of the triangle represents the boundary of the catchment. So your first rain gauge will have this much area of influence. Then your second layer will have this area plus that area. So this entire area. So this is for the polygon 2, station 2. For the station 3, it is this area. And the remaining area is for the this small area is for station 3, this small area alone. This is for your station 3. For your station 4, this area. So diamond kind of a shape, pentagon kind of a shape. So this is for your fourth area. So this is how we will draw manually, but same thing, our analysis, everything will be in QGIS. So we will do the same thing in QGIS. So for that we need to go to vector, geometry tools, Voronoi polygons. So Voronoi polygon is what will give you the perpendicular bisectors directly. And your input layer is the point, and your buffer region we can let's say 10%. This will be like a trial and error. It should cover your entire study area. So now currently we don't have study area, so it's not an issue. So you can see it has created the Voronoi polygon. So if I bring in the point, you will understand. So I will change the symbol of points. You can see the zone of influence for each point. So later we will be calculating for our other hydrology purpose. We will calculate the weight of the Thiessen polygon, weight for each station, and then we will use it for our analysis. So any other doubts you have with respect to GIS? You can ask anything from your assignment. I guess I have also discussed something related to your assignments. If you go through the PPT carefully, I think you will be able to answer all the questions. So especially related to projection, and there was some question with intersection or difference. Something was there. Then, is there any other doubt from any other week? So you can ask now. So this is the last week's lecture. Okay. So the recordings will be available in the YouTube channel, and all the materials data sets will be available in this Google Drive link. So I think I have already uploaded it. So week 8 you can see the tutorial data. So these are all the data sets which I used today. Only the soil layer will be missing because that's data set that which we are using for the product for our project, so we are not supposed to share that. Then I have provided the digitizing tutorial manual, then the map layout which I made today, so that is also here. So if I go down, so it will start from here. So step by step map is tutorial is given, so you can just go through and rewatch the video to work on your own. So I hope the 8 weeks interaction session was useful to you.